All right, if you have bought my SAT Packet Study Guide for Math, the book that I wrote, and you have done the packet on trigonometry, this question is super easy because I make it very clear. There are really just two things that the SAT asks you about for trigonometry, and the first one is the most important. That is SOHCAHTOA, right? So we should know what SOHCAHTOA is, what it means, and it's our way of understanding sine, cosine, and tangent, right? If we have a triangle, SOHCAHTOA means that the sine of an angle is going to be the opposite side over the hypotenuse. Now, look, we could draw a triangle because there's none here, but I don't think SOHCAHTOA is going to help us here. This is weird. There's no numbers in any of this. I don't understand what's going on, and these choices look a little scary. But if we did the homework, we do know that packet, we know the other rule. It basically comes in two forms, and they're equivalent. Sine of x is equal to cosine of 90 minus x, and cosine of x is equal to sine of 90 minus x. 85, 90% of the time, they're testing SOHCAHTOA, and it's about moving around a triangle. The other 10% is this rule, which I don't even know if I ever learned when I was in high school. I don't remember it, but I've seen it on the SAT, and if you remember that it exists, you're done with this question. If sine of x is equal to a, well, then cosine of 90 minus x is also equal to a, because that's the rule, right? Those two things are equal to each other. Done. That's the whole question. So if we remember this formula, then this is a 10-second question. If we don't, we might be able to figure it out, right? So I'll show you the proof for why these two equations are actually true. It looks like it's complicated, but it's not if we just understand basic trigonometry, right? So we can have a triangle and 90-degree angle, and let's make one of them x. So what do we know from SOHCAHTOA? Well, we know that the sine of that x is equal to the opposite over the hypotenuse. Well, it's kind of weird to have a triangle with no sides, so I'm going to give it some lengths here. Let's make it a nice 3, 4, 5 triangle because it's easy for my brain to handle. So sine of x in this case would be the opposite over the hypotenuse, which would be the 3 is my opposite side, and the hypotenuse is 5 because it's opposite the right angle. So sine of x is equal to 3 over 5. Well, if I then had to think about cosine of 90 minus x, that's kind of weird because that angle doesn't appear on my triangle. But it kind of does. Because how many degrees are in a triangle? 180. And we've got 90 of them accounted for here. So that means that between these two angles, there's another 90 degrees. So no matter what this x is, if that's x, this has to be 90 minus x. Right? So think about a triangle. It's a right triangle. So 90 is already taken care of. We've got 90 left to spare. If the x is 30, that other angle is 60. If the x is 45, the other angle is 45. If the x is 10, the other angle is 80. If the x is 80, the other angle is 10. They always have to add to 90. It's just the rules. So if I needed to do cosine of 90 minus x, well, cosine is always the adjacent over the hypotenuse. And now we're talking about this angle right here, and the adjacent side is 3, right next to it. And the hypotenuse is still 5. So look what we have here. 3/5, 3/5. Those are the same. So sine of x is equal to cosine of 90 minus x. My minus got a little lost there, but there's the rule. There's the proof. What's really happening with this rule is you're switching the angles in the triangle, right? So this is basically saying that the opposite side for one of the angles is also the adjacent side for the other angle, right? So that's it. And the same thing would be true if we flipped it around, right? The adjacent side for x, 4, is the opposite side for 90 minus x, 4. And so because all of trigonometry is about relationships and ratios, this works no matter what the triangle looks like. It's 90-degree angle in the triangle, we're good to go. This rule holds. Now for SAT purposes, I don't care if you understand why this rule is true. But if you want to pick up some easy points on a hard trigonometry question, just memorize the rule. And know that if this SOHCAHTOA thing isn't going to work, if you can't get it to work, then it must be this other rule. It's really the only other thing the SAT tests. So write it down on your page, see if you can make some matches, and sure enough, 90 minus x, oh my god, it's a choice. It matches perfectly. So it's not so bad if we know the rule exists. If we don't, yeah, this question looks really hard. So take this time to memorize this formula. Ideally, memorize why it's true, but if not, just memorize that both of these things are true. They're the only other thing the SAT really cares about. So it could save you 10 points, and it could be a quick 10 points, because as we saw, it's like literally just the rule in the form of a question. That's it.